Hi, I'm Andrew with AGL Mechanical Tips, and finally we get to do some basic sheet metal layout. In this video I'm going to show you most of the fittings you'll need to be able to do 90% of the duct systems out there. There's still going to be some stuff in between that you'll need to learn, but this will cover most of it. Let's go ahead and get started. So this is a basics video, so I'm going to start at the basics. If you already have some general sheet metal layout knowledge, you can go ahead and skip to a specific fitting. I'm going to timestamp everything in the description below. So if you want to circle back on how to make a radius elbow or something like that, that'll be listed below, and you can just find that and just skip right onto that spot. But I'm going to go through a couple things here. We're going to start with some common seams that are used in sheet metal layout. When you go to connect a piece of square duct, or you go to lay out a piece of square duct, you need to know exactly what seam you're using on that, and there's different seams for each application. Let's start with the most basic one here. This is just simply a 1-inch lip. Duct goes to here and it screws into that. It's simple. When I started my company, we didn't have a Pittsburgh machine, we didn't have a snap block machine. I made everything with 1-inch lips probably for the first year until I had a little bit of capital to buy some machines. I even was able to make a radius elbow. It's actually an octagonal elbow using this 1-inch lip method. And I've got a picture from 2006, which I'll post right here. Pretty cool. We then move into snap block. Snap block is very fast. It's probably what you're going to use for every straight section of duct or anything like that. This does not work on a radius elbow. But if you can see on my snap block fast video, it's super fast to put together. You're not in there banging with a hammer really loud and disrupting everything. So this is your snap block right here. It's just the fastest thing to connect rectangular duct together with. Snap block will not work with radius elbow. This turn right here, snap block won't work with that. And that's why we move into what's called a Pittsburgh seam. This has this little cut right here. And basically, depending on what size seamer you have, this was a 1-inch one, so I added 1 inch, ran this through my machine. Then I added a 1/4 inch to the male inside, and that basically slides in right like this. And you take a hammer to bend this over. This is a great fitting. A lot of sheet metal shops I worked for only had snap block. Pittsburgh. They did not have snap block because you can use Pittsburgh seam for rectangular duct. It's just a little bit more time consuming because you're having to bang over every section of that seam. So when you're doing 4-foot sections of duct and you're doing, I don't know, 200 foot of duct for, a commercial job or something, you're in there banging with a hammer all day long. So this works. It gets the job done for startup, startup company. I'd get the snap block eventually if you can. It's just super fast, super quiet, doesn't make a lot of noise. It's good stuff. As anxious as I am to lay out sheet metal right now, I've got to make a list, and I've got to communicate these fittings properly to the sheet metal shop. And believe me or not, that's actually a thing. So I've drawn out this standard duct system. Let's envision that this is a closet, and there's an air handler in this closet, and there's duct going from the air handler in the closet through the floor in the crawl space, and then running is a horizontal duct system right here. So we need to start with getting this duct out of the closet into the crawl space. So we need to make a radius elbow. The duct's going to come down and turn into the crawl space. There's two different ways to draw out. I could say 22 by 10 radius elbow, or I can say 10 by 22 radius elbow. Those are two completely different fittings. The way that we do it, or our standard as we communicate them, is the first number that you say is the turning side of the radius elbow. So this is a 12 by 10, this is a 10 by 12 radius elbow. 10 is right here, 12 is right here. If it was a 12 by 10, then 12 would be on this side and 10 would be right here. So I've drawn out these two fittings here. So starting out in this closet, we're going to need a 10 by 22 radius elbow because this duct system's running horizontal. So we're going to need this duct right here, 10 by 22. And I'll just make that 3D to where you can kind of see what's going on here. But there's a 10 by 22 radius elbow. I want to show you one other thing. If we don't specify a throat size, so this is your throat right here, then we figure it's a standard size throat, which is 4 inches. But you could do something like this, 10 by 22 radius elbow with a 14-inch throat on one side. What that'll do is it'll create a fitting like this. This is a 14-inch throat here. This is a 4-inch throat here. I do this a lot in situations like this because maybe, let's say that the framing was only 2 by 8 framing, and this throat allowed you to get through the floor and into your closet, you know, and you're going to set the air handler later, you might transition into it. So you just need this one fitting, and you're already up in the floor. You don't need to use a standard radius elbow and then add a S-lock and drive fitting with a piece of square duct here. You're kind of saving yourself one step. So I just wanted to mention that this is how we would write out radius elbows. 22 by 10 would be right here. And then 10 by 22 would be right there. Another thing we're going to touch on is reducers and how to communicate reducers. Right here I've got a reducer. This is the little symbol that I use. 22 by 10 to 16 by 10. So I've got a reduction going on here. And simply put, a standard centered reducer, meaning it is centered along this axis. You know, it's equal. I would write that out, 22 by 10 to 16 by 10 reducer. If I don't give a depth, which is the dimension here to here, then we know as a standard that we've communicated around this shop. You may need to, you know, describe this in whoever you're working with, but it's going to be 16 inches deep. That's our standard. But there's another way of writing this out. You could write 22 by 10 to 16 by 10 reducer flat on one side, and that'll create a fitting like this. And this is useful when you're, again, running through a web truss or something, and maybe the truss changes sizes, it ends up being smaller. Another thing I want to go over is how these numbers relate, because this is just a simple reducer where this dimension here is staying the same. You know, it's all 10 by here, but it's important to know that these numbers should relate in this manner. So 22 by 10 to 16 by 8 reducer, for instance, the 10 number is relating to the 8, and the 22 number is relating to the 16. So they would know that this is actually reducing on both sides, but one side it's going to be reducing from the 10 to the 8, and one side it's going to be reducing from the 22 to the 16. I also want to mention a double reducing reducer. So we've got one here. This is a 22 by 10 to 16 by 8 reducer. So if we write this out a certain way, the numbers could get flipped up wrong. For instance, if I wrote 22 by 10 to 8 by 16 reducing radius elbow, that's going to put my 8 dimension right here and my 16 dimension there. So if you're confused by this, you can simply take this fitting and draw it out like this, and you'll see that these numbers here are relating with each other, and these numbers here are relating with each other. So I've got my list here from the duct system I'm laying out here, and we'll start out with my 10 by 22 radius elbow with a 14-inch throat on one side. Remember, the first dimension is the side that it is turning on. And then I got my 4 foot of 22 by 10 duct that's right here. And I've got a reducer icon here. So I've written out one 22 by 10 to 16 by 10 reducer. I haven't specified a depth, which is going to put it at my standard size, which for me is 16 inches. Then I've got this section of 16 by 10 duct here. So I added 12 16 by 10 duct here. And then I've got one 16 by 10 radius elbow. So the 16 dimension is the first dimension here. So it's actually turning on the wider side right here. And then I'm going into another reducer, which I wrote out wrong, but it's a 16 by 10 to 12 by 10 reducer. And then I'm going into 12 foot of 12 by 10 duct and one 12 by 10 end cap. Now I wrote that out in the order of the direction of the duct system so that I wouldn't miss a fitting. This can always be reorganized in the layout room. For instance, I normally lay out reducers together as one group, radius elbows together as one group, and square duct together as one group, just because I'll get into assembly line process later, and it's just faster to do those fittings in that order with scrap metal and all that other stuff. But then below this, I did basically my basic material list for the job. You know, S-lock drives, roll of 2-inch mastic tape, 3-inch insulation, that kind of stuff. And I can't forget the Red Bull, so I added that at the bottom. Here's an air duct calculator. These are good for making some design changes on the fly. What they're mostly used for, though, is equivalent round to rectangular duct sizing. But when I run into situations where, you know, let's say I've got a flood zone I've got to clear, so I've got to keep my duct up high, or I'm in a web truss and I'm limited to my height, that forces me into rectangular duct. And I have a standard height that I always try to stick to. So whenever I'm getting into rectangular duct, I am trying to do 10-inch high duct. So shown right here, this air duct calculator, it shows you the round duct diameter, so I can simply slide over to 16-inch duct here. And you see it gives me all these different measurements that equals in rectangular sizing. The last thing to go over with rectangular sizing is, remember, the wider your dimension gets, the thicker the gauge metal you need. So 22 by 10 duct, I am barely still able to use 26 gauge sheet metal in 4-foot sections. If I'm going longer than 4 foot, I end up having to probably step up to 24 gauge, and in some situations 22 gauge. But if you're doing something like a 28 by 8 duct, you definitely need to step your gauge up. And that's why I'm sticking with normally this 10-inch height as well. Another thing I want to touch on is marking utensils. I got a couple different options here. No one is perfect. They are application based. Most of the time when I'm laying out on a nice clean table like this in a sheet metal shop with nice lighting above me on a flat surface, the perfect conditions I can have, I'm going to use a scratch tool. Either this or a scratch awl like this. I'd actually grip it like this, you know, and we normally sharpen it with a grinder or something. What's good about these is you simply put a mark. It is a very accurate mark. There's no thickness to the line, so your accuracy is really high. This is really good for template marking, which I'll touch on later, where you're making a template fitting that you're going to copy multiple times. And then a marker is another option. This is a better fit for copying templates, or when you're on a job site, on somebody's lawn, in somebody's driveway, on the bed of your truck, you know, where things are a little bit more difficult. The quality of these marker tips is also, it's good to have them new and have a nice clean sharp edge on them. And then I also want to show you, when you're using a marker, there's two different types of marks you can use. You can use what I call a V, which is like this, or you can use a tick mark, which is like this. I always use a V, and the reason being is when you're running a tick mark, you go like this, there might be a slight angle on it. You know, like when you're laying out sideways or something, you know, you're reaching over and putting a mark there. If it's at a slight angle and you come back to it later, you don't know which side was the accurate dimension. So when you do a V like that, I know that this is my point here. And also, you're gonna end up with a marker that's been beat up. You've marked lumber with it and done something like that. So if you did a tick mark with this, look at how thick that mark is. But in this setting, in this application, I would normally be using something like this, and I'd be actually scratching all of my measurements, and it would just give me more precision on my marks. We're gonna start with just a standard piece of rectangular duct. I've got that right here. If you know how to make rectangular duct and you know how to make an end cap, which I'm going to also show you in this video, those two combined will form a plenum box for an air handler. All we do is add a 1-inch lip and add our end cap, and we've got a plenum box for an air handler. So I'm going to start with showing you rectangular duct layout. In this video, I'll also be showing you an end cap, but just know that putting these two together forms a plenum box. So here's our piece of rectangular duct. When I made our list, I did our duct lengths in 4-foot intervals because we're going to be laying this out using 4-foot sheet metal. I rarely do 8-foot sections. You lose every time there's a seam, you're using S-lock and drive, which adds strength to your rectangular duct. And also, I'm a big fan of beaded metal. These beads in here actually add strength. You can do cross break, which is where you crisscross. It just takes a little bit more time with the sheet metal break, and I just like my beaded metal. I like 4-foot sections. That's personally what I do. Here's a piece of rectangular duct. This is actually a 22 by 10 duct here, but right here I've got a snap block seam, and I've got 10-inch dimension, 22-inch dimension, 10-inch dimension, 22-inch dimension, and I have my male seam. So we're gonna start with our seam over here, and you need to determine what seam you're gonna use. If you're on a job site, or if you haven't invested in a Pittsburgh machine or a snap block machine, you might be using a standard 1-inch seam like this, where the metal simply goes down into that and it's screwed off. I try to get away from this because it's not a very high quality seam. You have to tape it and seal it. Whereas the snap block, even if a section of tape was missing, it's still a pretty good sealed seam. But the advantages is you can transport a travel brake to the job site. In a pinch, you can quickly make that fitting, you know, and you can actually make most of the things that you need to build an entire duct system with just a standard 4-foot brake. It has its limitations and you lose a lot of speed, but you can do it. I'm going to start with a snap block on this. I've actually got me a cheat sheet here. This is specific to my shop. You can get a snap block in a different size seam, so don't write these measurements down. It might be different for the specific machine that you have. But I've got a cheat sheet here that shows all our different seams and what we're going to start with. Another thing to consider is where you put your female seam versus your male seam. I'll get to a point here, but right here, I've got the female seam for snap block. I have on this dimension of duct. The reason for that is when we go to press this into here, if I did it on the longer dimension, like this, if I put the female seam here and you're going to snap the male into that, this might bow when you're hammering it in. It's just harder to work with. So always put the female seam on the shorter dimension, so when you're working with the duct later, it's sturdier. You know, when you're hammering that snap block seam in, you're only pressing against a 10-inch section of metal and you're not bowing a 22-inch section. So I'll go ahead and start with the layout here. And according to my sheet here, I got 1.25 inches for female snap block. So I'm gonna not mark right at the edge of my metal. I'm gonna actually pull in about an 1.5 inches or so. And I'm gonna start marking inset a little bit. The reason for this is I'm not going to draw a line for every dimension here. I'm going to come in with notchers and just notch. It drives me crazy. I'll see guys, they'll be laying out a piece of 12 by 10 duct, just like we're about to do now, and they're going to mark their female seam right there, and then they're going to mark 10, and then they're going to mark their 12, you know, just like you normally would. Let's say they're going to come up here and do that as well. But then they'll go and they'll turn their ruler this way and they will mark every single line out like this. See every bit of time I'm burning right now lining up this ruler and marking up this line? This is a complete waste of time. They'll do something like this. Now, I used a dry erase marker here so I can simply take this off. Now, going into the way that I feel that you should be doing this is you set your ruler in, you carry it in about 1.5 inches. It's just got to be over 1 inch. Make sure it's straight on both sides. And I'm going to start by marking 1.25 inches, which is my female snap block seam. And then since we're building 10 by 12 duct, I'm going to then mark 10 inches. And then I'm going to mark 12 inches. And I'm going to mark 10 inches. And I'm going to mark 12 inches. Now on the end here, I need to have my male snap block, which is 1/2 inch. So I'm at a 1/2 inch here. Now normally I don't actually slide this ruler every time. I'm doing that for this video just for y'all to be able to follow. But normally I would do 10 inches, and then I would do in my head 12, which makes 22. The reason for that is I'm not creating a little bit of error. Every time I move to a new mark, my accuracy, I could be lining up my ruler slightly wrong on my V here. And when you get to the end of the duct, you're off by a 1/4 inch or 1/8 or something. So for accuracy, I normally just lay the ruler down and mark it all the way down. But you're doing math in your head on the fly, and errors can be created that way. So now that I have these marks here, I'm going to move on the other side of my duct right here. And I'm going to mark down here real quick. The only edge on this piece of duct that needs to be marked is this last one right here. And this is because we're actually going to be cutting this. So I will in fact come and put a line right here. We're going to go ahead and cut this line here. So we've got all our measurements prepped, and I've got a set of 1-inch notchers here, and these come in different lengths. This is a 13th, 16th notcher. You can get 1/2-inch notchers, you can get 1/4-inch notchers. They all have different depths. I personally am running with 1-inch notchers almost all the time. I'm normally going to be using 1-inch because it's setting my depth for other seams, which is something I'll show you in a little bit. But basically, I kept all of my V notches here. I kept them all slightly back, and I didn't draw a line through my duct this way because that's a complete waste of time. But using these notchers, this does square me up on my duct right here, and as long as I make sure that this tool is inserted properly and it's nice and flat, when I go ahead and notch this, I am right at my V. There was no need to draw a line. So because this is my male snap lock, I've got a notch this way, and I'm going to notch into that notch like this. That'll form the edge of my male snap lock. Then I've got my first bend here, my second bend, third bend. Then we have my male snap lock here. Now this male, it exceeds my 1-inch notchers. And this is why I use 1-inch notchers, because most of the time it does reach all the way through the cut. But I will still use this to start it up. I'm actually going to take it, see if I can get it in the camera here. And I'm going to line up my angle. See, I'm lining up this to where it intersects there. And I'm going to go ahead and cut it and leave it like that. It just makes a clean notch. And I'll come back and follow up with these straight snips here. You know, now I have a nice clean notch there. My angle was set with my notchers, but it was followed through with my bulldog. Oh, going back to bulldogs. Got a lot of comments on me calling these bulldogs. They're officially advertised as straight snips. That's what they are. When I was 17, 18 years old, or whenever I started doing heat and air, the first guy I worked with called them bulldogs, and it stuck. So you call them whatever you want. If I call them bulldogs, negative comments are always helpful to the algorithm, so I'm all for it. We're going to go ahead and do the same thing on the other side here. I've got my V notches there going the opposite direction, but that's fine. I'm still lining up there. I did mark this a little bit less than 1 inch, so you can see how my notchers end up covering it, and that's why I said to pull the ruler off a little bit. I can eyeball this close enough though, and it is definitely going to be accurate. There's my notch there, and go ahead and finish these off. And again, it's important to make sure that the back of your tool is not doing any angles here. It is nice and flat, because this method won't work if this tool is not flat. This is the layout for a piece of rectangular duct. I'll go ahead and run this through my lock former machine to put my female here. I'll also put my male here. Another thing I want to go over is I've got these beads that I personally like. I order all my sheet metal beaded. We do order flat metal for drain pans and stuff like that, and just to have around for transitions. So I've loaded my table bead up, so when I flip it out like this, it is bead down. And any marks that I make on this are going to end up on the inside of my duct. So when I break this duct, you're not going to see any of the marks on this sheet of metal. I've got my list of duct that I was going to fabricate, and I'm going to do this assembly line style. So I'm going to form a strategy in the most efficient way to produce all of this duct at one time. So I looked at my list here and I noticed that 12 by 10, I can fit 2 of these pieces on one sheet of 4 by 8 metal. So I'm going to do that because it's also going to save time and it's going to save us on material cost. I also noticed that my 16 by 10 and my 10 by 8, if those were all put on a sheet together, I can fit one piece of this and one piece of this per 4 by 8 sheet of duct. So thinking production style, I was going to do the 16 by 10 and the 10 by 8 together, but I'll show you the method I'm going to use just on the 12 by 10 real quick. So I need to produce 24 feet of 12 by 10 duct, and if I'm getting 2 pieces per 4 by 8 sheet, then I need 3 sheets of metal for me to produce that amount total. So I'm going to go ahead and load my table up right here. I put 3 sheets of metal already on my table, and when I dropped it on the table, I slightly slid each piece over the next piece here because I'm going to start marking on this edge, and I don't want to mark on the sheet that's below it. So when I was thinking ahead, when I dropped this sheet, I then put the next sheet on slightly over. I've got my template piece right here under the layout table, and I'm just simply going to take it. I'm going to flip it over like this, and I will slide it right here. I will make sure I'm square on the edge of this sheet of metal, and this is why it was important to slide. I'm going to mark all of this. I'm going to mark my line right here. Then I'm going to take it. I'm going to kick it over. I'm going to mark all my notches, mark my line right here. I'm going to mark all my notches there. And I'm going to take this template piece, because this is my template. I don't want to mix with my next sheet because, as I mentioned earlier, the notches would get slightly off. I'm going to stick this sheet right back under here. I'm going to notch this. I'm going to cut it. When this is all cut and made up, I'm going to then take this piece and I'm going to set it in front of my female snap lock machine facing the side that's getting the female snap lock. That way, on the next stage would be me running all this metal at one time, and it's already in a position to be ran. So I'd cut this, notch it, move it there. I would cut this other section, notch it, move it over there. Then I would be pulling my template back up and marking the next section. So I could produce this 24 feet of 12 by 10 duct probably in like 5 minutes, maybe 10 minutes, somewhere in there, but extremely fast, a lot quicker than just sitting here marking and cutting every single piece. This is our completed piece of return duct here. This can also double as your return plenum for your air handler. You know, we did use 1-inch notches on this. It's another reason I like using 1-inch notchers is this can easily become a return plenum, and we can just bend this down and boom, we have a 1-inch lip there to screw to our air handler, and you can add an end cap to the other side. So by using this same method, you know, if you got an air handler that needs a 20 by 20 return plenum, you're basically doing the same layout. You may change the depth on it, so you'll add another line to cut it, but it's basically the same thing. You're just adding an end cap and a 1-inch lip, and I'm going to be showing you that end cap here soon. Next fit we're going to make is a end cap. This is a very easy fit, and there's a couple different ways of bending it after you've laid it out. I always grab scrap laying around for this. It's a smaller fit. You should always be looking for scrap to burn. And one thing you need to pay attention to is here's a piece of scrap and it's got a little curve on the end of it here. So that's not going to be a good edge to mark off of. So just whenever you're using scrap, make sure you keep a close eye on what's square, because this is pretty close, but it is off, and it will be off enough to make a difference. So this fit in here, to make an end cap, I need a 12 by 10 end cap. We just basically need a 1-inch border all the way around this piece of metal to make an end cap. So I'm going to start by marking my 1-inch. And I'm going to mark 10 inches, but I'm just going to cheat the ruler here and mark it at 11, so it's actually 10 in between. Then I add another 1-inch lip. Move up here. We're going to do 1-inch lip, 10 inches, cheated to 11, 1-inch lip. Then we're going to come around here. I'm going to do my 1-inch lip. Then I'm going to do 12 inches, but I'll cheat to 13. 1-inch lip, cheated to 14. Come over here and we'll do 1-inch lip again, and we'll do our 12-inch and our 1-inch lip again. This is one where you do have to mark out every single line. So I'm going to go around marking this out. And again, if I was not on the field or if I was not on camera, I would be using a scratch tool for this and it'd give me a little bit more accuracy on my lines. So we've got our end cap marked out here. It's basically 1-inch lip, 12 by 10 in the center. I went ahead and extended this line all the way out to where when I cut through this, it leaves me another piece of scrap to make another end cap over here without having this awkward, piece of metal hanging out. I'm gonna go ahead and cut this out. One thing I wanted to bring up is that when you're cutting metal, this left hand is actually bending the sheet metal up to get the metal out of the way for this blade to cut, and it allows you to cut much faster. I mean, I can just zip right on through this when I get my material, this material out of the way. I also cut this in first because it leaves me with less here to deal with when I make my other cut. So that's our end cap. We have notches to put on this. Now this does not use a standard, I think this is 30-degree V notch here. It does not use that. And the reason being is when we go to break this, if we do a standard notch, this lip, it will end up hitting this other piece of metal in the break. So we actually have to do a complete 45-degree cut right through here like this. So this is our 45-degree notch. We're going to take all of this here out. So this is our end cap, laid out, notch, cut, everything. It's done. You can template mark this, but it's not really the most useful thing to template mark. I'll show you real quick if you were to template mark why. So just going to simply mark this out real quick. We'll add a line right here, just so I'm cutting a square piece of metal here. So this is called we call it a tree scribe. I don't really know exactly what it's called, but it resembles a Christmas tree on the edge. So we call it a tree scribe, and everybody here knows what it is, so I'm gonna keep calling it that. But basically it gives me different dimensions here. And what we need is, we need a 1-inch mark so that when we slide this into a break, we know exactly where to break it at. That's why this doesn't make for a really good template, because you could just simply mark out very quickly, a 14-inch by 12-inch square piece of metal, and then just come back and tree scribe it. But basically you just take this, put it on each edge, you'd zip a little line there. You don't even need a full length, just enough to where you can line up a sheet metal break. So that gives me a long enough line for me to accurately put this in a break and make my bends. So I'm gonna show you how to break this real quick. You simply just slide in the break like this. And I talked about those shallow notches not working. This you'll be able to see right now. But I'm gonna put a 90 here. I'm not gonna turn this fit, and I'm gonna come to my next line. I'm gonna put a 90 here. And the reason I didn't turn it is because I've got a quick stop. If I set my break real shallow like this, it's a quick stop. It stops me right on it. And I'm going to bend until I start kinking a little bit. I'm not kinking there. I'm right at a 90. Set my break real shallow. It stops it. I actually have to back it off a little bit. And there's what I call a new school end cap. When you go to put this on the duct, this is one fitting that goes inside of the duct. It does not go on the outside like this. But when you're installing it, instead of sitting here fighting it in like this, you can simply put it in like this. This is on the inside. You're going to screw this side off, and then this will form a hinge. You'll lift this up, and you'll tuck these other two ends down, and then you'll hinge down and screw up your sides. But this is the one fitting that goes inside the duct like this when you go to screw it off. And I was bringing up notches again. See how that big notch is exposed here? There's a big hole here. If you were doing exposed rectangular duct, this would be the one fitting where I would do a lighter notch. I'd probably do like a 1/2 inch notch here at the end, just so if it's exposed duct, it's in conditioned space and you're not going to put any mastic tape on it just because it'll look ugly. You'll have a smaller area of leakage there. Again, it's leaking into conditioned space, so it's not technically leakage, but cosmetically it will make a difference. Now we're going to get into some more complex fittings, and I want to start with a radius elbow, but I've got a process here that'll make this fitting simple for you once you see this video. This is what we call a tight bend radius elbow, and it's called a tight bend because this is a sharp throat here. It's just making a direct 90-degree turn. A long bend radius would be more of a curved inside throat here. But typically in residential, I'm using this more than anything else, probably because of space. And I'm normally in a web truss or something. I'm having to make a sharp turn. I don't have a choice of making a long bend radius. So I'm going to start with laying out the cheek side of this. So this is the cheek. This is what we call the throat. And this is what we call the wrapper. I'm going to start by laying out the cheek. And I found some scrap metal laying around my shop. This is a great fitting to burn through scrap because there's a bunch of small pieces. It drives me crazy when I come into my shop and see somebody laying out a small radius elbow on a 4x8 sheet of metal when there's a pile of scrap metal laying in the corner. So I found this long piece here and I found this other piece here, and I'm able to make this whole fitting out of just stuff that we would ended up throwing away. So we're going to start by laying out this cheek side here. And I confirmed that this piece of metal is big enough for this. And I'm going to start by laying out this, what I'm going to call the throat portion of the cheek. So I'm going to be forming the cutout for this. And it's also good to mention the seam we're using on this. So we're going to be using a Pittsburgh seam. The reason we're using a Pittsburgh is this will flex. This can flex like this and will form our bend right here. You're actually seeing this laid out right here like that. But this is what forms the throat section, which is just simply a 1/4 inch lip. With your specific Pittsburgh machine, this could be different, but my machine is a 1 inch. We lay out 1 inch for female and 1/4 inch for male. Everything on this cheek side is going to be my male, and everything on the throat and wrapper is going to use my female seam. So I've got to add a 1/4 inch to everything that I lay out on this side for this seam to exist later. So I'm going to start by marking out my throat. We just have 4 inch here and 4 inch here. Now I'm going to mark 4 inches to cover the distance from here to here. I'm going to back it down a 1/4 inch to give me my seam that's my male Pittsburgh seam. But then I'm going to go ahead and also mark my 12 inches up here. So I'll slide the ruler over so you can see this. But I'm going to mark 12 here, and I'm going to add a 1/4 inch for my male Pittsburgh that's going to be on the top portion right here. I'm going to also do the same thing up at the top of my sheet because I can't draw a straight line unless I have 2 points. So I'm going to mark my 4 again, back it off a 1/4 inch. I'm going to mark my 12 from here to here, and then I'm going to add my 1/4 inch. Now, I'd normally do this math in my head and I wouldn't pick up the ruler and move it because every time I move the ruler, I'm affecting accuracy of my marks. But for the purpose of this video, I'm sliding it over to where you can see what's going on. So I'm going to do what I did here. I'm going to do the same thing, but I'm turning it 90 degrees. So I'm putting my ruler here, marking my 4, backing down a 1/4 inch. Then I'm marking my 12. I'm going to cheat that to 16. Add my 1/4. Come over here. We're going to mark the 4, back up a 1/4. Mark my 12, which I'm cheating at 16. And then I'm adding my 1/4. So then I'm going to mark out my throat here. I'm not going to draw this line all the way through. I may put it at the edge here. I'll show you what I mean in a second. I'm putting a mark right here. This is covering this section here. There's no need to draw it all the way through. And then I'm going to come over and mark the additional 1/4 inch I added there for that seam. So you end up with this right here. That is my 1/4 inch Pittsburgh seam. And then I'm just going to do the same thing again. And I'm going to come over here and I'm going to connect these lines. I'm only going to connect this outside line so that when I cut this fitting out, my scrap metal is good. You'll see what I'm talking about here in a second. This next line, I really only need to mark 4 inches. So let me just do this. Let me set this to 30 and I'll stop my mark at 34. So there's what I end up with there. I'm going to turn it perpendicular. I'm going to draw my outer line all the way through. The reason for this is I now have a good scrap piece of metal here. But my next piece, I only need to mark 4 inches. Out here, here's our throat, and we now need to create our radius bend here. So I've got a set of dividers here. Looks very much like a compass. This is what I'm going to use to draw the radius of my elbow. They have different kinds here. Here's another one by Malco. These are mainly meant for doing like way big radius elbows because I can spread this way out here. Problem is I find that these are hard to adjust because whenever you release this, it moves slightly. So I typically stay with this style here. And I also want to tell you, when you're on a job site and you realize that you had to make a turn and the sheet metal shop, you didn't want to call the shop and have a radius elbow made, so you're field fabricating something like this, and you don't have a set of dividers or for whatever reason, you can run to your truck and say, well, I do have thermostat wire. So boom, here's a piece of thermostat wire, and I do have 2 nails. You can simply just take this wire, wrap it around that nail, take it around this other side. You'd have to measure your distance here, but you'd wrap that around. And basically you've created a set of dividers here in a pinch. So that's just a little quick tip there if you're in a pinch. And that also works great if you're having to draw a circle in a subfloor or something to cut out for, you know, toe kick grill or whatever. Cool little trick for when you lose your dividers. So I'm going to set my divider by simply putting it right here on this mark and then dragging it over to here and holding it here. And then I'm going to lock it down. Right there. Now it's important that when you lock this down, you're not at an angle here. You don't want to be measuring from there and be at a slight angle here, because as you can see, that doesn't line up no more. It only lines up right at this 4-inch mark here. So your pivot point is going to be right at this edge right here, right where these 2 pieces of the throat intersect right here. And I'm going to go ahead and put a little dimple there, just so that when I'm moving this around, my pivot point's not changing. So I've now got this divider set at 12 inches, and I'm just simply going to take and scribe my outer edge here. And when I did that, I didn't put a lot. You don't want to bend this thing out, because when you get to the end, it'll be outward slightly. But I'm then going to take this and I'm going to unlock it. I'm going to open it back up to my next notch here. And I'm going to scribe that. So our pattern's laid out here. We measured our throat 4 inches. We backed off a 1/4 inch. We added our cheek distance here, which is 12, and then we added another 1/4 inch for the male side of our Pittsburgh. We then marked all this out, and then from this point here being our pivot point, we basically continued this mark all the way around using our dividers. We're now going to cut this out. I like to cut out the outermost edge first so that I can work with the fitting easier later. And straight snips will cut this radius. I'm lifting up with my left hand and I'm cutting with my right. You can cut this out with a pair of red snips. It will be easier as you make your turn. The reason I use straight cutting or bulldog snips in my world is it leaves it's a cleaner edge. If you cut with snips, you might not be able to see it here in the camera, but there's a little serrated edge around this cut line here. And this is gonna be running through this Pittsburgh seam here. And every one of these little serrated edges could catch on this, and it could start what we call a kink. And if you start kinking and running out, it could ruin your fitting. So I like to cut with straight snips. It just gives me a nice, flatter, sharper edge, and it fits into this groove a lot better. And cut out my center throat here. And then there's an important notch I'm going to add, and this notch is just simply a snip right here. Let me actually draw this out. I'm just going to put a snip right there. I'm just going to put a little cut line here so that we can fold each of these individually. Now we have to do our notches here, and you got to envision that this duct is connected to another piece of duct. So the V notches are going to go in like this. Basically, I cut this one, then I cut this one, and I'm turning it perpendicular, and I'm cutting the remainder here. Do the same thing here. Here is our template piece for our radius elbow. You've got your throat, this is your outer wrapper, and we've notched it. This can be copied. This piece doesn't matter which way it's copied because it's mirrored on both sides, but if you did a fitting that had like a longer throat on one side than the other, then you'd have to keep track of what's the inside. So if like this was the inside of the fitting, we'll just write inside. When you go to copy this to another piece, you'd want to flip it upside down because that would be the inside of your other piece. All right, very, very important. Do not go and bend this piece. Every single radius elbow, you should be using your measured piece to template your second piece. Every single one. There's no reason it should ever be any different. So here's my first piece. Drop it down right here. What's nice about this is I can use this on scrap pieces that don't even have a square edge because I can mark completely around this fitting if I wanted to, but this does have a square edge, so I'm just going to simply come in here and we're going to go ahead and mark this around. If you do care about your scrap, you could go ahead and mark your square edge here. So that when you cut this out, you're left with a better piece of scrap. We've got our template piece traced out onto our other piece, but we have to add this line here that'll allow us to add the 1/4 inch lip later. So we're gonna go back to our tree scribe here, and on it there is a 1/4 inch. We actually turn it sideways for this, and I'm just gonna scribe 1/4 inch mark here. You're not gonna see it on the camera, but there is a very slight 1/4 inch mark on my fitting here. I'm gonna go ahead and take that and do that on this inner edge as well. So when I go to bend these, I now have a line to bend against. Quickly show you how to go ahead and put your male seam into this. And this is a tin knocker manual flanger. I've got a nice automatic flanger back there that is down currently at the moment, so we're gonna have to make this work. But in this manual flanger, I've got a little notch right here that we've added with a grinder. I just simply took a grinder and added that notch. But you basically put the corner of your metal right in here, and I'm going to bend almost a 90 there. That gives me like a starting, it's just a starting angle. So I can then sit this, I basically can sit this right in place here. And I'm going to ride, there's actually an edge here I'm going to keep my eye on. And there is a line in this metal here that I scribed on. The camera's not going to pick it up, but I'm actually driving this down the line that we scratched onto this with our dividers earlier. And I'm just simply going to make sure that my tension's right here. And there's my 1/4 inch flange. You can see I changed directions with it, and I put a little kink in there when I was doing it. So it's good to try to do this in a nice smooth action. So we've made our outer flange here, and we need to make our inner flange. You can simply push this right at the table. If it kinks that, that's okay. When we go to fit this fitting together later, the method we're going to use, it's going to pull that kink right out. But you can use hand tongs for this. And I've got a 1/4 inch mark here that was scribed on this. You can't really see it, but there is an actual 1/4 inch line right here. And there's a 1/4 inch line right here. This is going to serve as a depth gauge for my hand tongs. And I'm just going to simply take these and I'm going to put them to that line there. I'm going to push this hard against the table and I'm going to bend up. Slide it over a little bit. I didn't need to slide it. Then I'm going to come over here, put it right against that line. Put it against the table, bend up. So now that we have the cheek side made, we're going to go ahead and make our throat. And our wrapper. We're going to make both of these fittings at the same time. This is a 12 by 10 radius elbow, 12 here, 10 this way. So our throat and our wrapper is going to be the 10-inch dimension, and we're just simply going to add the 1-inch lip that'll form the female Pittsburgh seam. There's a way to calculate the radius right here using pi, but we found it just easier to simply take this fitting, lay a layout ruler out, start right here at the very edge of your ruler, and just simply roll this fitting down, and I'm going to keep rolling it. And I come up with 27 1/4. I slid a little bit at the end there, so I'm going to do it one more time just to see if that comes out to be the same measurement again. Yep, I've got 27 1/4. It might not be a bad idea to add an 1/8 sometimes, just because the thickness of the female Pittsburgh on bigger fittings, it might actually end up being a little bit longer. So if this is a bigger fitting, I might add an 1/8 or 1/4. But I'm going to roll at the 27 1/4 on this. So that's going to be the length of my wrapper. And we already know the length of our throat is going to be 4 inch here and 4 inch here. So we don't have to do anything with that. So we're going to mark both the wrapper and the throat out at the same time. I'm going to come to my metal. We already have our width here. And I'm just going to mark 27 1/4. Put a line right there. And slide my ruler over. And now, so that's my wrapper. And I'm now doing my throat, which is 4 inches plus 4 inches. And I'm going to come down here and I'm going to copy that again. So, whoops, my ruler is not straight. That's important that your ruler is straight or your measurements won't be accurate. So 27 1/4. And then I'm just going to slide this over to 30. I'm going to mark 4 inches here. And I'm going to mark another 4 inches. So wrapper, throat. We're going to draw our lines in between. And now if I had my ruler, we don't really even need to mark this line out because I can get my notcher close, but I was off here. I'm just going to go ahead and put a little line here just for my notches. And then we'll draw out this line here. So I don't recommend drawing this line out because when you're cutting, you might get into a rhythm and you see a line, you want to cut it. So if you don't draw the line, you won't cut it. We're going to go ahead and cut these out now. Start by cutting the outer edge out first. cut this long line out. Then I'm going to cut my throat apart from my wrapper. Now we have our two fittings here, but we still need to notch it. So your wrapper is a little funny because you've got notches going two directions. You've got your notch here for connecting to your square duct. Then you have your notch here. You can have one on the end as well. So when we run this, we're going to run this side through the Pittsburgh machine, and then you'll end up bending it, so you'll have a female here to interconnect here. And then on our wrapper, it's just a double notch on each corner. So we're going to run our female Pittsburgh on these two pieces of duct here. You want to make sure that you're running it through on the right seam. We don't want to run this seam. This is our throat piece, so we're actually going to be doing the shorter edge here. Also, I keep my scratch marks or my marker marks up because this ends up being the inside of the fit, and if it was exposed duct, you just don't see any marks on the outside. So I'll be running this through, and then I'll be running the long edge of my wrapper through. So I ran my wrapper piece through right here, and there's something I wanted to mention. It doesn't work with this specific machine, but this wrapper here, it needs to have a curve on it like this. And some Pittsburgh machines don't have so much of an overhang here, and you can actually lift up the metal as it's being ran through the Pittsburgh machine and actually give it this radius as it's being fed. All right, so my machine, I just thought of this. I think it's too fast, and that's the reason why I can't pull up on my material and get the radius bend on it. So I'm gonna actually try to slow that machine down, which takes parts and headaches and all that kind of stuff. But until then, I can show you how to use a roller. So this is basically just a roller. It's gonna allow me to provide to put a radius on this. If you don't have one of these, you can still fit this to a radius elbow manually. As you're hammering it in, you can actually make this bend, and it does work. It makes things a little bit more difficult. This machine here, I just simply flip this back. I've got a lever right here that allows me to lift up this dowel, I guess I'll call it. And then I'm gonna put this metal in probably about 3 inches because I've got a throat there. I'll lock it down here. So I'm now locked down, and then all I have to do is simply turn this. So that gave me a radius here, and you can adjust the bend by adjusting these. You can adjust the tension and how much pressure it's putting. But if you're off a little bit, this will flex a little bit when you're fitting the fitting together. So we've got our wrapper bent to fit the radius, and our cheek is done. We have to bend our throat piece so that it properly fits in here. And it's just a simple 90-degree bend, but the reason I bring it up is it is a reverse bend. Do not slide this in the brake with these lips like this, because you're going to be upside down. It's not going to fit into your fitting. You need to make sure that it is inserted like this so that it can capture the edge here. So basically it's upside down when you insert it in the brake. All that's left is for us to assemble this fitting. And remember I mentioned earlier that when this was on the table, if this kinks, it's no problem. That's because there's a method to connecting this that will pull these kinks out. I also mentioned this in the Snap Block Fast video. It kind of shows what I'm about to go over. But basically we want to start this out by lining this fitting up in this groove. We want to make sure that this corner is perfectly flush here. And we're just going to simply hammer down that edge there, So you can see this loud and noisy and it takes a long time, and that's why I like snap lock when we're doing straight duct. Basically, you're going to just start hammering this around, but you want to keep, if there's a kink right here, see that kink? If you bend up, that kink gets pulled out. So we want to be pulling up as we're hammering this in to allow this fitting to pull in without getting kinked and it ends up coming out the groove. So I'm going to go ahead and hammer this around here. So we got our wrapper done here, and this takes a little bit of practice getting this fit in. It is hard. Even for me, it was hard. I did have one section that kinked on me. I was able to recover by using a flathead. It's going to happen. Just make sure that your 1/4 inch lip that's coming off of this cheek side, make sure it does not exceed a 1/4 inch, because if it does, it won't bottom out all the way. Now all we have to do is put our throat on here. One thing I always do is I take my 2 fingers here and I just bend the middle section here. I just bend that out. That's my starter. And then I slide it in here. And I get it started right in the middle there. I'm always banging towards myself. So I'm always doing it kind of like this. Once you get your center started, you can just tap this in. That is our completed radius elbow. I'm going to show you how to make a reducer. And I wrote out here 16 by 10 to 12 by 10 reducer, 16 inches deep. This is the top piece of my reducer. I didn't specify flat on one side. Had I specified flat on one side, this fitting would be squared off here, and there'd only be an angle on one side. So because I didn't specify this when I wrote this out, we're going to center this fitting. So it's going to be a centered reducer, 16 by 12 to 16 by 10 to 12 by 10, and it's going to be 16 inches deep. We're going to start by laying out this top piece. And to do that, you simply start by marking the depth of your fitting. So I'm going to do 16 inches. There's no seam here. There's no lip. So it's just the straight 16 inch. I'll come over here and I'll mark 16 again. And I'm just going to draw this line to connect the two. And then I'm going to mark out the 16-inch dimension here, but we're going to make this out of snap lock. Most people would make a reducer out of Pittsburgh. That's perfectly fine, and most of the time I do either or. I'm going to use snap lock because it's quicker. It's a straight seam, so you can use either or, no problem. Here is my snap lock, and I'm going to do the top piece. I'm going to make that my male. You can actually do either or side, male or female. It doesn't matter, but I prefer to do my top piece using the male. So I'm going to start by marking my 1/2 inch lip, but I'm not actually drawing off of that mark. I'll explain that here in a second. Then I'm going to add 16. I'm going to give myself another 1/2 inch for this lip here. So that marked out the top portion of my fitting. Now I need to mark the bottom portion, but because this is not flat on one side, I need to find the center of my fitting to give me this dimension. So I've got a 16-inch fitting here, but I added a 1/2 inch lip here. Also added a 1/2 inch here. So the total fitting size was 17 inches. We're going to divide that in half, which is 8.5. So I'm going to mark 8.5, which is just giving me the center of my fitting. There's the center of my fitting. Now I need to mark in this 12-inch dimension. I'm only going to mark the 12. I'm not going to add my 1/2 inch seam, and I'll show you why. So I lined up 6 with my center mark, and then I marked 12 inches here. And I'm going to connect these 2 inside lines here. So I've got my gap for my sheet metal here, connecting that there. And then I've got the end of my fitting here, which with my 1/2-inch lip, but I'm not connecting it there. So we're connecting it just like this. Now the reason I didn't mark another 1/2-inch lip here is because the more this angle changes, the more that lip will end up becoming smaller as this angle changes. So you actually have to go in and add these marks off of the line that you just drew. So there's my new 1/2-inch line there, and I'm gonna add it to this side as well. I'm just using the end of my ruler for this. And then we're gonna draw that line out there. Now at this fitting, if I marked out a 1/2 inch, it probably would have worked out, but if I did a very steep angled fitting, this 1/2 inch would probably end up being somewhere like, I don't know, 3/8 or something in the end. It wouldn't work. So this is drawn out. I'm not gonna square this off for scrap because after I cut this, I'm gonna flip this fitting over and I'm gonna copy it. So this actual angle here is not my scrap metal yet. So we're going to cut this out. With these notches, I do bottom this fitting out like this. Cut right here. Then I'm actually going full 90 degrees from this line here. See how I have some play here? I'm actually lining it up here and estimating when my tool is perfectly at a 90. I'm cutting that like that. I'm going to do the same thing here. Same thing on this end. Now the notches on this worked out fine, but when you get these very steep reducers, you'll find out that your notches get really funny. And you need to be thinking about how this is going to actually connect to the next piece. You want to make sure that this angle allows for S-lock and drive to be hooked up to your duct later. So this is our connection point. If this notch was out here, when we went to make a connection here, it would conflict with our S-lock or drive. So after you lay this out a few times and you get good at laying out reducers, you'll start thinking ahead of how the fitting's going to actually work. And just keep this in mind. You'll see, oh man, that notch might hit my S-lock and drive. It's something I can't really explain, but from experience, you'll be able to circle back to what I'm saying here. So this is a completed top piece for the reducer. We're just going to copy this to give us our bottom piece. So boom. And how I mentioned earlier, how I wasn't going to square off this material, I didn't need to because, you know, this simply works right here. One thing I want to mention though is I wanted to use flat metal on this, but I wanted to burn through my scrap. So we've got beaded metal here. If this is exposed ductwork, I am OCD. I would actually lay it out like that so that these beads line up. This is getting insulated, so it doesn't matter if these beads line up. So cosmetically, I'm going to go for metal conservation here, and I'm going to mark it out like that. We laid out our top piece, we copied that to make our bottom piece, and now all we have left to do is make the side right here. One mistake that is commonly made is this fitting is 16 inches deep, but when you start running an angle here, this piece right here is longer than 16 inches because you've now added an angle. And the steeper this reducer gets, the longer this piece of duct is going to be. So instead of just marking 16, we need to actually measure along this edge right here. So you can just simply throw this down in front of a layout ruler. And I can see here that this one is about 16 and an eighth. So it's not that much longer than 16. 16 probably would have worked, but when you get these really steep reducers, you might end up adding an inch to this fitting to make it work. We're going to be using female snap lock on this side piece. So we're going to have to add 1.25 inches for this female snap lock. If you're using Pittsburgh or a 1-inch lip method, that distance is going to change. It really depends on what seam you're using. I have 1.25 inch snap lock here, so I'll be adding 1.25 inches to this. So we're going to start by just simply marking 16 and an eighth, because that is the total depth of our fitting. We'll come across, make sure our ruler's square, and we're going to put 16 and an eighth. Then we're going to draw a line. Now we're going to add our female snap lock to a square edge here. This edge is our remaining scrap. We can't measure off of that no more. I'm going to pull this 1 inch off the edge so that I can use my notchers to mark this out. Mark 1.25 inches. Then the depth of my fitting, this is a 16 by 10 reducer. We're making the 10 side, so my depth is 10. Height of the fitting is 10. And then I'm adding my 1.25 inch snap lock again. I'm then going to come up here. I'm going to pull my ruler 1 inch off of this other line because I'm going to use notchers. I'm not going to mark out every line like I explained when I was making a piece of square duct. I'll mark 1.25 inches. I'm going to add my 10 inches here. And I'm going to add another 1.25 inches. Now we're just going to draw this one line here. And I kept this notch a little bit further away from my edge. I should have that closer. So I'm going to mark that here. Mark that here. But if I didn't have this notch out floating into space, I wouldn't need to draw a line at all. I'm going to go ahead and cut this out. We're going to do our notchers here. So remember how I said you don't have to draw this line out? That's a time-saving thing. So cut your notch right at that little mark there. This side, I put my notches in the right spot. So see, I can just simply make sure that this is squared up, lock that down. And then this is our 1.25 inch seam here. It's a little bit longer than my 1 inch notchers. So I'm just going to guesstimate where that angle lands. And I'm going to go ahead, for production reasons, I'm going to cut all 4 of them at one time. And I'll come back and finish this off with straight snips. This is one of our sides. We're going to now take this, we're going to flip it, do our other side. These are our finished side pieces. Now, very easy to run the wrong edge through your snap lock machine, and if you do, it is instantly, trashed. That's why I kind of like using my female snap lock on this, because it's 1.25 inches, and I can actually see that this is a bigger lip than this. So we're going to run this through the machine on the 1.25 inch side right here. So we have our completed transition here. All we need to do is snap together. There's our female snap lock, 10 inches. Here's our 16-inch side, our 12-inch side, and it's got our seam for it. So we just simply snap this in place here. Make sure my edge is lined up here. I do want to mention this is popping right in. When I'm banging with my hand here, I'm not hitting this very hard. If you do need to hit it hard, use a rubber mallet or something. Got a lot of comments about me bending metal with my hands on the previous video, so I appreciate that, but I figure I'll just mention that this isn't hard to snap in place. It's not causing any damage here. This is our completed fitting here. As you can see, you can use a Pittsburgh seam here. You can use a 1-inch lip screwed. I chose to do snap lock, but you can make it out of any seam you want. Couple quick tips to go over. Using assembly line process with sheet metal layout is probably one of the most time-saving things you can do. When you have a list of all the fittings you need and you template form everything and you get your metal on the table first and you come up with a process, you're thinking ahead, like when I cut this, where am I going to set it so that I can roll it through the lock former machine and stuff like that. Any of those things are huge time savers. And when you have a pile of metal to lay out, it will really cut your day in half. When you're on a job site fitting rectangular duct together, I always recommend keeping a piece of S-lock on a job and also keeping some scrap sheet metal in the truck. You never know when you're gonna have to make a fitting on the fly. And this always works as a great layout ruler, straight edge. You can also use it to bend 1-inch lips. It's just good to have around. I went over a wire method that you can use if you don't have a pair of dividers. I can't tell you how many hundreds of times I have lost my dividers or broken a tip or had something like that, and I was able to simply use a string and 2 nails to either draw a radius elbow or draw a circle on a subfloor or whatever. It's just a really good way to be able to draw circles in an emergency. When you're cutting sheet metal using your straight snips, you want to lift up on the metal when you're cutting to get the metal out of the way of the blade. You'll find that it is much easier to cut. And always remember, measure twice, cut once, double check your fittings before they go to the job site. There's nothing worse than getting to the job site and realizing your radius elbow is off by a 1/2 inch and your whole job is shut down. I hope you like this video. I plan on doing more sheet metal videos in the future, so hit the like and subscribe button. I'm Andrew with AGL Mechanical Tips, and remember, quality is your reputation.